Hello student, I am Dr. S.L. Munde, Assistant Professor, Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in a previous lecture we have seen half-range Fourier sine series formula, concept and theory part uh, of this topic. Okay. Also we have seen some formulas of a half-range Fourier sine series. So in this lecture we will see the another problems on a half range Fourier sine series. Already we have seen one problem in previous lecture. So in this lecture we will see the second problems on a half range Fourier sine series. So before going to start problem, so first I will repeat a formula that we will use to solve the problems. Okay. So what is the half range Fourier sine series formula? If the function is order type, if the given function is a order type, then the half range Fourier sine series is given by. The formula is given as f of x equal to summation n equal to 1 to infinity bn sin n pi x upon capital L. Okay. And here bn is the coefficient of this series. Bn is 2 upon capital L integral 0 to L f of x sin n pi x upon L dx. Okay. So these are the formula to solve the problems. Now we will see the second problems. So what is the second problem? Express the following function in terms of the Fourier sine series, and the given function is given as 1 by 4 minus x in interval 0 less than x less than 1 by 2, and the value of f of x in second interval, that is x minus 3 by 4 in interval 1 by 2 less than x less than 1. If you observe this function f of x given in two interval, that is 0 less than 1 by 2, and that is second interval is 1 by 2 to 1. Okay. So total interval is 0 to 1. Okay. So this is the half interval and this is the second half interval, and the total interval is 0 to 1. Okay. So therefore here we can say that minus L is 0 and plus L is 1. So therefore here capital L is 1. So putting capital L in our formula. So what is our formula? That is f of x equal to summation n equal to 1 to infinity bn sin n pi x upon capital L. Okay. So if you observe, so this function is a odd function. If you check this function is a odd function type. Okay. So the formula is given as f of x equal to summation n equal to 1 to infinity bn sin n pi x upon capital L. So here L is 1. So put summation L equal to 1, summation n equal to 1 to infinity bn sin n pi x. So this is our main formula. So here bn, coefficient of this term, that is bn, can be written as 2 upon capital L 0 to capital L f of x sin n pi x upon capital L. But we know that capital L is a 1. So put L equal to 1, so this can be written as 2 times integral 0 to 1 f of x sin n pi x dx. Okay. If you observe from this given function, so this interval divided into two interval 0 to 1 by 2, 1 by 2 to 1. So now we will split this integral in two parts, that is 0 to 1 by 2 and 1 by 2 to 1. We can split. So this can be written as equal to 2 in first bracket integral 0 to 1 by 2 f of x, the value of f of x in this interval is 1 by 4 minus x sin n pi x dx, plus second integral 1 by 2 to 1, and the value of f of x is x minus 3 by 4 sin n pi x dx. Okay. So here we have split up the given integral, this integral, into two part. Okay. Now we will integrate. Okay. So here we will use the formula, that is integration by part, we can say that, or Kronecker integration method to solve this integral. Okay. So what is the Kronecker integration method formula? So the first function into integration of second function, that is 1 by 4 minus x minus integration of this function, that is minus cos n pi x divided by coefficient of x, that is n pi, minus sign. Okay, minus sign, derivative of this term, that is minus 1, into integration of this term, that is minus sign minus integration of cos n pi x upon n pi, that is sin n pi x divided by n pi, and this n pi. So this can be written as n square pi square, and limit should be the 0 to 1 by 2, plus 2 times multiply to this integral, so plus 2 times in bracket. Again we will use formula Kronecker integration method formula. So first function x minus 3 by 4, integration of second function, that is minus cos n pi x upon n pi. Minus sign is compulsory, plus minus in this way we can take. So minus derivative of this term, that is 1, into integration of this term, that is minus sign cos n pi x integration, that is sin n pi x upon n pi, and this n pi. So this can be written as n square pi square, and integral should be the 1 by 2. Limit should be the 1 by 2 to 1. Okay, and third term will become 0 because derivative of this term will become 0. So we cannot write the third term. Now we will put upper limit minus lower limit. Okay, so by putting upper limit instead of x and lower limit instead of x, okay, the upper limit and lower limit of this term, if you put in this bracket, so you will get this term. If you put and solve and rearrangement the terms, so you will get this term, okay, up to this term. Okay, so this is the expansion of this first bracket. Okay, upper limit minus lower limit after putting the upper limit minus lower limit. Okay, then second term. So the solution of this term is given as this term up to this term. Okay, so if you put up upper limit then minus lower limit in this term, so you will get this second this term and this term. Okay, in this way you can obtain the putting the values of upper limit as well as lower limit. Okay, so you will get this step. Okay, now we will put or we can say that we will solve this bracket or these steps. Okay, we know that sin n pi is 0, sin n pi is 0, so this term will become 0. Okay, then if you observe minus 2 upon n square pi square sin n pi upon 2, and this term, that is this minus 2 upon n square minus pi square sin n pi upon 2, can be written as 4 times upon n square pi square sin n pi by 2. Okay, so these steps can be written as in this way. Okay, the solution of this term. What is next? We know that cos n pi by 2, that is the cos n pi by 2 is that is 0. Okay, so the total the solution of this term is 0. Now sorry, so if you observe this term, if you multiply to this term, so this can be written as 2 to get cancelled, so plus 1 upon 2 n pi cos n pi by 2, 2 n pi by 2. Okay, and this term will get cancelled. If sorry, this term and uh, this term and this term will get cancelled. Okay, so only remaining term is here cos n pi. Only remaining term is cos n pi. Okay, cos n pi and this term. Okay, so if you solve, or you can, if you solve, you have to add 1 or 2 step here. then you will get, putting the value of that is cos n pi, that is minus 1 to the power n. Okay, so you will get these steps. Okay, the solution of the cos n pi by 2 term and cos n pi term, you will get this term. Okay, so this is the value of the bn. Okay, now for the simplicity, we can find out the b1, b2, b3 and b4 and so on. Okay, so if n is a odd, then it will give the values. So if n equal to 1, so put n equal to 1, you will get 1 upon pi minus 4 upon pi square. If n is even, then bn term will become 0, b2 equal to 0, b3 is 1 upon 3 pi minus 4 upon 3 square pi square sine 3 pi by 2. So that is 1 upon 3 pi plus 4 upon 3 square pi square. 3 pi by 2 means that is 1. So b4 will get a 0 and b5 will get 1 upon 5 pi minus 4 upon 5 square pi square. In this way we can find the value of b1, b2, b3, b4, b5 and so on. Okay, now we will put all these values. Now we will put all these values in equation number 1. In equation number 1. Then the equation number 1 can be written as f of x equal to b1. F of x equal to b1. If you solve this, so you will get b1 sine sine pi x. Sine pi x. b2 sine pi x. b3 sine pi x. b4 sine pi x. Okay, so we have already find out the b1, b2, b3 values. Okay, so first term will be b1 sine pi x, that is 1 upon 2 minus 4 upon pi square sine n pi, plus b2, b2 is 0. Okay, there is no need to write. b3 is 1 upon 3 pi plus 4 upon 3 square pi square sine 3 pi, plus b4 is 0, b5 is 1 upon 5 pi minus 4 upon pi square sine pi x, plus and so on. In this way we can write the remaining term. Okay, so this is the expansion of the Fourier series in interval 0 to 1. Okay, so this is the second example on a half range Fourier sine series. In next lecture we will see some another example on this topic.